time for some mechanics. And so this is just a velocity time graph, which is quite a simple thing to do, but at the same time there's 5 marks for it, so you've got to be really careful to put in all the detail that's needed. Although it's a sketch, so you don't need a ruler or anything like that, but you do need to be clear in what you're doing. So we're going to have a vertical axis, and up the side there will be velocity, and time always goes along the bottom. So velocity, and you should put your units in there, so that's going to be meters per second. And then we're going to have a load of time going along the bottom, and that's going to be in seconds. Then what are we told? So the first thing that happens is it goes with constant acceleration of 11 meters per second for 8 seconds. So if we put a little thing in saying 8 is there, and having done that, it stays at the same velocity, then it comes down. So that's going to be the highest velocity that it gets to after 8 seconds. So we need a straight line going up to there, and because 8 times 11 is 88, we really want to be putting in 88 there to show that that's the speed we're going at that point. And then it's going at constant, it's maintained for t seconds. So we don't know how long t is. So you've got a choice. You can either put a bit in like that going t, or t plus 8 actually on there is what they liked in the mark scheme. Personally, I quite like doing that. As long as it's clear what you've done, it doesn't matter. You don't need both of them, you just need one of those. So this should be a straight line going across, and as long as it looks intentionally straight, that's what matters. If you're worried, then by all means use a ruler and maybe a pencil at first. Then it's decelerating in 2 seconds to reach that. So if that's 8 seconds, we want a small amount more there. So that would then be t plus 10, wouldn't it? Or you could just be putting in a little bit there saying 2, but you want to be noting that. And then we're decelerating to 40. So 40 is going to be a little bit under halfway. I note 40 on the velocity axis, and then I'm going to be having a straight line sort of coming down to there, and it'll stop at that point. The most errors I saw were people coming all the way down to here, but also not labelling clearly what was happening on the time axis. Right, then, given that the distance between A and B is 1,404 meters, find the value of t. So I would now use this to set up what I'm going to be doing, because the distance between A and B is on a velocity time graph is the area under the graph. So if I was to dot that down, what I've actually got here is this area. Now I would call this into A and B and C, and then just work out each one separately. So my A is going to be 8 times 88 would give me the rectangle, so divide that by 2 to give me the triangle. So that's 352 meters. My part B is just a rectangle, so that's dead easy. That is just 88 times t, so whatever that is. And then C, well, that is a trapezium. So a trapezium, remember, is the area of a trapezium is a half A plus B times the height, or some people like to do half of the average of the parallel sides times the height, whichever way round is all you need there. So we're going to be having a half, and you've got your 40 plus 88. So that 88 is that length, 40 is that length, and then we're multiplying that by the perpendicular height, which is actually your horizontal bit from 8 up to that was 2 seconds, wasn't it? So that'd be timesing by 2. So actually, if you halve it and then times it by 2, you're just getting what those two add together to make, which is 128. All of this means we can make an equation, since we know that the distance is 1,404 meters. So we can say 352 plus 88t plus 128 is equal to 1404. Then if you add those two together, you get 480. So 88t is going to equal 1404 minus 480. So that is 924 divided by 88. T is going to equal 10.5 seconds.